Right. Last lecture, what we cover in chapter 4 is the keyword is network. There are two types of network, AOA, AON. AOA, you will have dummy. Okay, you have node and arrow. AOA means activity on the arrow. AON is activity on the node. Okay, so you have your activity here, and the date is time is below the. For AOA is activity and time is on the arrow. For AON, your activity is inside the bubble or inside the node. Activity, right? Okay, so a general ideas of network will be from node to node, you cannot have double arrow. Cannot have double arrow from into or parallel to the this one. So that's why in AOA you need to use dummy. This one is wrong. So you need to use dummy. And dummy, for dummy, the arrow is dot. Is dot shape. Okay. Now yesterday also what we learned to find critical path. Okay, critical path. There are two presentation. One is node to node. Another one is you change the node into rubrics. Okay. And there are four ways of finding critical path. Okay, there are four ways. So first one is the normal way by path plus calculation. Means you identify how many path, the path, right? The path, and you calculate the time or duration. Okay, then you pick the time. Okay. Second one is you look at the middle part of this one. ES equal to LS. This part. Okay. The third one is EF equal to LF, which is the third component here. The last one is the S or slack. Slack equal to LS minus ES or LF minus EF. Okay. So there are four methods. After that, yesterday we also learned about probability of normal curve. Okay, we introduce you the most likely time frame M, optimistics and pessimistics. This is A, this is B. And we have the estimated time, TE. We give you divide by 6 because your curve split into 6 area. That's why you divide by 6. And you, on the top, you sum up the area. So A plus m, you have 4 parts, so 4m plus b. We also learned that there's a variance with the square, b sigma square equal to a minus b divided by 6 square. Standard variation is a square root of sigma square, which is b minus a divided by 6. Okay. And also, we calculate the probability, which is the z equal to x minus divided by mu, x minus the okay, we have this equation, x minus mu. Okay, so mu is the project mean time. So project mean time. So this is the mean time you calculate from your analysis, right? X is a proposed project time. Z is a number of standard variation from the mean. So this one is the Z lah, the value you read from the table. Okay. So these are the important formula. So this one you should be very familiar already. Okay, like I mentioned in previous class, there's no reason you don't know how to solve this question, because inside the appendix graph they already have a formula there. Okay. And what is inside here in the middle part here is the probability. So let's say I pick one number, for example, 0.4788. 0.4788 means what? 47.88%. What is the green area, or what is this 47.88? You see the graph, right? Got this color. So this number 47.88 means the area of this color. So you no reason you don't know unless you really totally you fail your statistics or you fail your mathematics. But if you fail your mathematics, you won't come to this module. All right. So you already passed your mathematics, so you should able to do this question. Okay, I already upload these PowerPoint slides on the this one. PowerPoint slide is until here. So for today, I think I need to go a bit detail on how to solve. So if you read the statement, blah, 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 it's a statement there. Important that is you see this network here. So network, if you see three numbers, the first number is A, middle number is M, the third number is B. Right? For example, activity number 1 or node number 1, you see 6, 8, and 10. 6 is referring to A, 8 is referring to M, 10 is referring to B. So these are the formula that we expected to see in your solution. Okay, write this formula in your answer. Right? Then you build a table. Okay, you build a table. All these things you read, it will tell you which one by which one. Okay, which one by which one. So it will tell you either you see a table or you see an essay form. The activity. Activity 1 go to activity 2, activity 3, and so on. Okay, there are two ways of we ask you question. Either we straight away give you a table, or we give you a paragraph, essay, something like this. Then you read and then you build the network. Okay. So usually we give you activities, time estimate, bracket, weeks or months. So we give you A, M, and B. You need to calculate the mean time and variance. Mean time using this formula. Variance using this formula. So we expect you to build this 2 lah. So in my slides, I highlight there already. So you need to calculate. Okay. So most likely optimistics and pessimistics. So optimistic on the left, pessimistic on the right. Remember to write the equation, then show one line of example. Okay. Yeah. Reminder, don't come late in my class. You come late in my class, you might miss something important. Okay. Okay, so once you calculate the mean time and variance, sometimes the question will ask you to ask for critical path by either one of the method. It will force you to use either one of the method. This example forces you to use slack time method. Okay, so if the question asks you to solve using slack time method, you need to build a table. Okay, you need to build a table or convert this network time, this shape into the box format or Rubik's format. Okay, so these are the SOP, the steps. Okay, yeah, repeat. So in exam or test, you either see essay form, paragraph like that. Okay, or a table form like that until activity, time estimate, A and B until here only. Okay, then you build this one. Okay, so the first method of present question, you will see paragraph, something like this, like which activity, activity 2 must fit to activity 5, for example, like this statement. Once the system is developed, bracket activity 2 is tested manually to make sure it's logic bracket activity 5. So this statement, it means activity 2 go to activity 5. Like this one. 2 go pointing to 5. Okay. So this one, we expect you to convert all these things into this form. Okay. And we give you one table like this. Okay. Yes. In option, sometimes you can skip this one. You can straight away use this one to go into this shape. But usually you need this one as your sketch. You draw somewhere in the sketch, in the space there. You sketch because you want to know where the arrow pointing. Then you can straight away use this format. Understand? Usually this one you can skip one because this one it got 3 number. Usually I won't see, I don't ask you to present like this lah. Yes. It depends how we ask you question. For example, if we give you a paragraph and then we'll ask you build or construct a network, and I give you something like this. I give you by representing your node as shown. I give you this one. Then I show you this one, activity. This one I show you duration of time. Okay. If I ask you this one, you repeat the same as what you see on the screen here. Only you need to, this one, duration of time is TE, expected time or mean time. You need to calculate this number. Okay, so if the question give you like this, yeah, if the question asks you like this, it give you build a network with a node as shown. Then I give you a bubble. I give you, then I show you on the top must put activity node, activity number. Then below is duration or time. I won't write TE. I just give you duration of time. You need to smart enough to see below one is actually is a TE, or you need to calculate the mean time. Yeah. Then you build the network same as this. The shape is like that, but don't put the three numbers if the question asks you or force you to use the presentation of node like this, what I draw on the whiteboard here. Understand? So these are the way we try to ask you. And just for your info, the tutorial question you see that I show you in the class, I won't ask you because it's already there. So I cannot ask the same thing in the exam. But we will modify it a little bit to just to test you whether you understand or not. Okay? Okay, so this one, don't put your answer like this lah. Just put your answer. The blue color one, don't write 222. For example, activity 7, don't write 222. You need to calculate, for example, from this table, you need to replace the 222 become 2. Okay, how to get the 2? By the formula. Okay, A plus 4M plus B divided by 6. Okay, put in start and finish. Put in start and finish. So some of you might ask, Dr. Ang, if I forget to put start and finish, can or not? Usually I will give you pass lah. If you forget lah. Unless the question already mentioned, you need to put start and end. Then if you don't do it, then there's a deduction of marks. It's a good practice to put start and end in your network. Okay. Okay. Clear? So this one you need to do some exercise. Do some exercise. So yesterday we already learned about how to build this one, how to get the numbers inside the box already. You learned about forward pass and backward pass yesterday, right? So let's say this is your network. Let's say this is a very simple network. So let's say you have 4 activities, all right? So this one is the time you calculate from the formula. Okay. So let's say this is 1, 3, 4, 5. All right. So we have learned about forward pass. Forward pass. So forward pass, usually we start from the left to right. Forward pass, let's say the one that you see on the whiteboard here. 1, 1, usually this one is 0 because nothing in the front. How to get the number here? You just add 1 plus 0, 1. Right? So then you pass the number to here. You pass the 1 to here. You pass the 1 to here. Then you add the number. Here, then you need to choose already. 4 or 5. So forward pass, choose maximum. So choose 5 here. Careless mistakes is here. One this wrong, then the rest wrong. Yeah. So of course later I will discuss your test 1 paper after we finish this one. Okay. So this one is 10. So from here and then we have done the top one already. We do backward pass. So backward pass, you start from the back. There's nothing on the back here. So you copy the number. Yeah. So sometimes you have 2n. You have 2n, a bit tricky. Sometimes you arrive at 2 box, then n. Let's say this is 10. Let's say this is 12. The critical time is 12, not 10. Let's say you have 2n. Okay. When you have 12 here, the number that you should put here is 12, not 10. I need to stress this one. Okay. This is the careless mistakes. Usually, if you write 10 here, your backward pass will be wrong already. Means all these are wrong all the way. Okay. This one yesterday I didn't mention, but this one come out once last semester. So most of the student, if they listen, then they know. Those that absent class 1 or come late 1, they screw up the whole question. Okay. So again, okay. This one, the LF, latest finish, this number, you need to refer to the maximum time you have. Let's say you have 2n, pick the maximum time. Not just copy that. Okay. Then this one you do forward pass, backward pass. This one is 5. So copy the number. So this one 2, this one 1. So this one got 2 and 1 to choose. So choose minimum. Choose minimum. So this is 1, 0. Easier to check. Every time you do question, you can do your self-check one. Usually the first item, 0, 0. If you do backward pass, you do not get 0, something wrong in your calculation. Okay, usually 0, 1. So if this is the one of the final checking. If you do backward pass, not 0, something wrong in your calculation here. And then careless mistakes will be here. The last one, like I mentioned, the whiteboard. Choose the maximum numbers. Okay. So from the one I draw at the whiteboard, can you identify the critical path member? This one. This one not. This one. This one. Why? Because the middle box is the same. Third is the same. And you write critical path double dot activity number 1 dash 3 dash 4, for example. Then project minimum time to complete the project is 10 something lah. You need to read the question lah. It can be 10 months, it can be 10 weeks, it can be 10 days, depend. So in this case it's 10. 10, let's say this one is week, then I put week. Yeah. Okay. So these are the careless mistakes area. So just take note. For your batch, I think I just allow you to have crossing your arrow. Right. Okay. So from the PowerPoint slides here, are you able to identify the critical path member? Just looking at the diagram there. Which are the members? Which are the members? First one is what? 1, 2, 3. Which one? Okay, where's the attendance, please? UV, which is the first member, which the critical path member? Huh? Activity 2, huh? Activity 2. Next one. Dinesh, you here? Which is the second member? Two already. Then this is the next critical member. Huh? You follow the arrow, You follow it. First one already 2 already. So you follow the arrow. 5, huh? 5, Then you follow the arrow. So this one, you follow the arrow. So this one again missing lah. There's I think some error there. So this one, I think it should be go to here. So there's some one arrow missing on this diagram. So go to 8, then go to 11. For example, this one, you see, the one that I mentioned on the whiteboard there. You see how you choose the 25 number? Here, when you do the forward pass, you see your earliest finish, this box, 17 and 25. When you do backward pass, choose the maximum number. When you want to pass back, do not write 17 here. This will be the careless mistakes. This will be the careless mistakes. So choose the maximum number from the back. I need to highlight this one because I like to ask questions, something like this. Okay, take note. Take note. Don't just copy 17 here. You write 17, you pass back, the whole line will be long. Yeah. Okay. So critical path, remember, you write 2, go to 5, go to 8, go to 11. From this table, what is the minimum time to complete the projects? 25 what? Days, years, weeks. Okay. So once you have completed the rubrics or the network, if the question forces you to identify the critical path members by slack time analysis, you need to extend your table further. Means when you answer this question, you can rotate your answer sheet like that, then build a table, something like this. All right. So you can extend, or you can just build another table to write all these things. This one you copy from your network, all this ES, EF, LS, LF, you copy the numbers into this table. Then you calculate the slack time. Slack time, there are two calculations. Either you calculate the middle part or the one on the right. Okay. So from the table here, activity number 2 give you 0. Activity number 5 give you 0. Number 8 give you 0. Number 11 give you 0. Okay. So your answer will be from the table. From the table, slack time with 0 is the critical path member. So the critical path is, you write, is 2 dash 5 dash 8 dash and 11 dash 11. This is how you solve it, how you answer the question. Okay. 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 Then the question will ask you, compute the total project variance. Total project variance, this one, you only calculate the variance for the critical path member only. So the one you can see on the slide here, Member number 2, number 5, number 8, number 11, they are the critical path member. You calculate the variance from b minus a divided by 6 square. So you just extract the value here lah, from the table. Don't add all. This is also one of the careless mistakes. Always check your number double 2 times. Every time you press calculator, check 2 times. Because once you press wrong, all the calculation wrong again. Yeah. This one, for variance, if can, you a minimum, in this case, two decimal place is enough. But when it comes to your probability letter, if can, you have 3 decimal place is good for your calculation. So you put in the numbers, right? You put in numbers, variance, you put in a number 1 plus 0.11 plus 1.78 plus 4. You get one number. The variance is 6.89 weeks. Okay. Who don't understand how to get this one? Who don't understand? Who don't understand? Suddenly you get 6 point something. Can I? Okay. Okay, we have done with the first example. Okay. Now this is the first part of the question. Usually, the first part is the table and the network. This will be in the second. Second part will be example number 2. So you see the company in example 1 was told by customer that new order processing system will be operational in 30 weeks. What is the probability of the system will be ready at that time? What is the minimum project time? What is the minimum project time? What is the minimum project time? 25 weeks. Now the customer asks you, can you complete in 30 weeks or not? Yeah. If the customer requirement is more than the numbers, usually your percentage will be more than 50%. Your answer will be more than 50%. How you do it? You use this formula. Z equal to X minus micron divided by mu. You have variance of 6.89. You need to square root it. This will be also the careless mistakes. Some of you straight away pull 6.89 here. And then you estimate the wrong things already. Okay. You know that your mean time is 25 weeks from your analysis earlier from the network. So the customer proposed 30 weeks. Put in the correct sequence. X is the one that your customer want. X mu is your maximum project time, 25, right? So as what I draw on the whiteboard here, this line here is this is the middle. So this something somewhere lah, So this you draw a line. This is your T. Sorry, not T. This is your mu. Your project time. This is your project time, or you can put TE there. The percentage is here. Sorry. This your curve peak is your TE. This one is your X. So X. So you put in the numbers. Your Z is 1.91. 1.91, you go to this table. You 1.91, where is 1.91? 1.9, you have 0.0, 0.01. So 0.91 is this one. You don't have to read out. Because your Z value is 1.91. So go to the table. Straight away, you can do interpolation if you want, but that is a long way. Straight away, read from the table. You can interpolate this one and this one, depend. So you can take these two number and then you do interpolation, or you can put 1.9 and 2, then do interpolation if you want. But straight away read from the table. 1.91, 1.9, this one is 1.90, 1.90. The next one is 0.91. So it's 0.4719. Yeah, and last sheet, you can do interpolation if you want, but you read from the table here, 0.91. Okay. Sorry. 0.91 is here. This one. I enlarged the section here. It should be this one. Okay. So you pull the area. This is your project time. The curve middle is your project time. This one you read from your analysis from your network. Maximum 25 weeks. And this is your customer expected time. You can read graph. As you move towards right, the number increasing. As you move towards left, the number decreasing. So the customer asks you, can you complete 30 weeks or not? 30 weeks is on the right hand side of 25. So you draw, in your solution, you draw the curve of this one. Draw the middle point, you write mu 25. You draw one line here, x equal to 30. So you get from the table just now, from the table 0.4719. Where is it? It's on this one. This area is 0.4719. If you cannot see it, I flip back the graph for you. Moving the mouse. It already show you the area of your Z on the top already. You see the colored area? The numbers that inside this graph or this chart is the one colored with color. Understand or not? So the maximum value you can go is 0.499, which is 50%, which is half of the curve. So the number for this example, you get 0.4719 is the one that color here, which is 47.1%. Okay. So you continue solving the question. It asks you, what is the probability of having project time 30 weeks? So 30 weeks, you look at the left-hand side, the area to the left. It's the total area you calculate from x equal 30 to the left. So 0.4719 plus another half, which is 0.5%, 0.5. So total is 97.19%. Understand? In your answer, we expect you to write this one. Probability bracket x, x and then less or equal 30 weeks means the area to the left. Then you label, you point to the colored area. Use your pen to cross the area. So you write probability of completing the project in 30 weeks or less equal or you can straight away write this equation. It's okay. Right here, 0.4719 plus 0.5 equal to 0.9719 equal. This is area for the curve. The answer I'm expecting is in percentage. 97.19%. You will success. You will able to complete the project in 30 weeks. Okay. All right. Okay. Now, some of you might ask, what happens if the customer give you a value less than 25 weeks? How is the calculation? I give you example number 3. Same scenario. Now the customer asks you, can you complete in 22 weeks or not? What is the probabilities? You do the same process. You draw the curve. Right? You draw the curve. What is the curve? You draw the curve again. Middle one is 25. Mu. 22 is where? Left or right? Left. Because as you move to the right, it's more value. The one on the left is reducing. So 22 is here. The value you read from the table is what? This area. Always colored area from the middle. Right? So this one, what area that actually you need to calculate? Here. Why? Because this line is P x less than or equal 22. Right? The one that I label with bubble. Can you see it? So this one, you read from table. Later, you need to take 0.5 minus this value. Make sense or not? Make sure you understand. No, it's on the left because the customer now asks you 22 weeks. Means you don't understand the curve. You don't understand statistics question. Yeah, draw something on the whiteboard. Okay, I give you another example. Let's say you build a network. I assume you build a network. Okay, let's say you have 2 N. I give you 15 and 25. What is the project time for this project? 55. Okay, let's say weeks lah. So you draw a curve. Middle one is 25 weeks. This is your mu. Your x is depend on what your customer want, right? So you have the whole graph is 100%, and you have half already. 50% is over right, 50% is on the left. Inside the chart, you see a fraction number or decimal number. You will see maximum area of this one is 0.4999. On the left, also 0.4999. But in the table, it already show you the area highlighted by the color. If you use the calculation of z equal to x minus mu divided by the sigma. Okay. Now, let's say the customer asks you, can you do it in 26 days? Where's 26? It's on the right-hand side of the middle part. You draw here. You write 26 here. Then your area always from the middle. This is the area you want to get. How you get the area? By using this formula. Z equal, how you get sigma? This one from your calculation. This one from critical path member. This one from, you do the calculation, then you calculate. This one. So you have one number, let's say I just put it 2. Let's say you get 2 for the sigma. So X is the customer request. 26 minus this one is 25, for example. So you get 1 divided by 2. Cannot be 2 it can be something else. So this is how you get it. So the area is here. So if the customers ask you, it depends on question. So this one is able to complete in 26 days. If the question asks you, you also see 26, but the question asks you, what is the probability if you not able to complete within 26 days? This one is you able, not able, this side. Or you need to spend more than 26 days. The question you should put, what is the probability of the project it need more time than 26 days, weeks? Probability that it need more time is this line, right? Here. So you need to take 50% minus the probability here. You need to read the question carefully. Where is the area of that one? So if the customer asks you, what is the probability that it can complete, let's say less number, 20 days. 20 days will be here. Right? So 20 days will be here, but your probability, can you complete within less than 20 weeks or not? It's over here, this area. So to get this area, you need to put 0.5 minus this area. It depends on how the question asks you. There's no, you need to understand where you get the area. It's not so direct. Not so direct. So for example, this one, the customer asks you, can you complete within 22 weeks? Within 22 weeks means your probability equation will be P bracket X less 2, for example. So less 2, your graph is this area. Let's say this 22 is on the left, this area. So to get this area, you need to find the area over here from the table. Then you take 0.5, 50% minus this one, you get this one. When you need to use this area, if the question, I change it to, what is the probability of your X is within 22 weeks to 25 weeks? Then you read directly from the table. Understand? It depends on how we set the question. Important you understand which area refer to what. This is a very easy score marks. Very easy to score question. Either you know or you don't know. Yeah? But need some time if you're weak in statistics. So again, you read from the table. Okay. You calculate, you get negative already. Actually, there's a hint there. Negative means it's on the left-hand side already. You get negative value, it's on the left-hand side already. Means it's on this side. It's on the left side. Then you go to the table, you go and find 1.14. Where's 1.14? You can do interpolation or straight away go to the table. 1.1, 1.14. You go to, don't read wrong, this is 0. 1.1, 1.11, 1.12, 1.13, 1.14. 0.3729 is this one. Here. Okay. Okay. So again, 0.3729 is the one that in this blue color. The value that you read from the table is the one that the blue color one. But this time, because your value is negative, is another side from the middle. Understand? The question asks you, will you able to complete within 22 weeks? Means your maximum time is only 22. It's better you complete less than 22 weeks. Or you give me the products less than 22 weeks. Where is less than 22 weeks is from this line to the left. You write P bracket X less or equal to 22 weeks is this purple color area. How to get this purple area? The half section is 0.5 minus 0.3729, you get this number. Yeah. Answer is 12% only. Very, very low probability you're able to complete within 22 weeks. This one you can calculate one. You as a project manager, you can know whether you can or cannot. If you come up with probability of 12% and you still agree and you sign the agreement, most probably after the project you will be fired because the success rate is so low. Okay, so the question will ask you, you as a project manager, what is your decision? The decision will be no go lah. Do not proceed because the probability percentage is only 12.71%. Okay. Any question for this one? Any question? Just a quick quiz. We go for a short break. Before I go for a short break, I draw something on the whiteboard. See if you're able to understand. I assume you already get the project time is 50 weeks. I assume you already know how to get this one. Sigma is maybe 2 point something, 2.5. Okay, I assume you already know how to find the sigma already. What is the probability of completing this project within 60 weeks? Okay, I give you this table. I give you this chart. Maybe a bit small, but I give you this chart. Same. Okay, this one is available in Appendix A in Canvas. This one. So what is the probability of this one? Okay, I end the recording. So this is just your quiz question.